section 5.6. It has to do with inequalities of triangles, just like what we've been talking about before. But this time we're going to talk about two different triangles. We're going to compare two triangles, not just one triangle. So in the last lesson, we just compared the sides of one triangle. So we said this is just quick review. If this side is smaller than this side, right? That one's bigger than this because I put the tick marks. What does that tell us? Whoops. What does that tell us about some of the angles here? So and I'll tell you what. I'll put this like a medium. Is that all right? So that's the smallest side. That's the largest side, and that's the middle side. So what's the smallest angle in this triangle? Angle C, so that's the smallest one. What's the largest angle in this triangle? Angle B, because it's opposite the largest side. And then the medium one, the one that's in the middle, okay, kind of like the three little bears or whatever they call it. Is that what it is? I almost said three pigs, but that's not the same story, is it? With the porridge and the big one, the little one, and the one that's just right or something like that. I don't know. All right. So listen to me. All right, just let me babble. You don't need to comment. Just let me say dumb stuff, okay? And just look at me and shake your head, and we go on, okay? That's how it should work. So look, this is dealing with one triangle. There's a big difference between what we're going to do today and what we've done in the past. This is just dealing with one triangle, talking about the sides and the angles of one triangle. Now what we're going to do is we're going to compare two triangles to each other. Now, this is kind of similar, to something that we've done in the past. And if I had, let's not make this so big. If I had these two triangles right here, I copied and pasted. So what do you think is true about these two? They're congruent to each other. We don't say the same. We say they're congruent to each other. Do you agree? And there were different ways we could prove them congruent. We could say side, side, side. Agreed? So watch. This side is equal to this. Well, sorry. It's not equal to that. But let's say this side is equal to this side. This one with 2 tick marks is equal, and this one with 3 are equal. So those triangles are congruent because of side, side, side. Agreed with that? What if I did this, though? Let me ungroup this. What if I took this side? I kept the length of it the same, but what I did is and let me get it to match up. I kept the length exactly the same, didn't I? Yeah. So let's put these right on there like that. Okay? So that length is still equal to this length. This length right here is still equal to this length. But if I'm going to make a triangle out of this, what am I going to have to do to this length right here? I'm going to have to extend it. What's it going to be? If I make this angle bigger, right? Right, this one is going to get longer. Do you see that? So that definitely got longer than what it was before. Would you agree that this definitely looks longer than that one right there? Yeah. So I can't put 2 tick marks on that anymore, can I? Because they're not equal to each other. So guess what I just did? I took this angle and I made this angle bigger. Let's make it look. Watch. I made this angle bigger than this angle. But I kept these two sides exactly the same. Would you agree? So what do you think that we could say here? If I have two sides equal to each other and my included angle are unequal, right? Which means if they're unequal, one's got to be bigger than the other. Would you agree? Okay, so watch. If I have two sides that are equal to each other, this side is definitely equal to this side. I didn't change that at all. This side right here, all I did was just change the angle. I didn't change the length of it. This side right here is exactly equal to this side right here. What's the only thing I changed? I changed this angle. I made it bigger than this angle right here. What do you think it did to the opposite side then? Right, it makes it, watch, I'll go, so that side is going to be bigger than that side. You okay with that? Now they don't mark it like that in the book. I just kind of made that up on my own. But we can visually look at it and say, oh yeah, that's got 2 tick marks and that's got 2 tick marks, but those are a lot bigger, so that's a bigger side. You okay with that? So what we call this, now they call it something weird. I'm going to call it the way that I'm used to calling it. Is that all right? But if you look in the book, they give it a different name. I like this name better than what the book does. I call this, or the book I used to teach out of anyway, calls this the side. It's not just side angle side, because this angle is not equal to this angle. Would you agree? It's not equal. It's called the side angle side inequality. They call it, and I'll put it in parentheses, they call it the Hinge theorem. Why do you think they would call it the hinge theorem? Because look, what you did is you took that length, you didn't change the side of it, but what did you do? It's like on a hinge. Do you see it? It kind of goes like this, and I just changed the angle. All right, so that's why they call it the hinge theorem. It was kind of, it was going straight across, and what did I do? I took it and turned it like this, kind of like on a hinge. Right? You get the idea? But I like my way better because it kind of explains what's going on a little bit better. They call it the side angle side inequality. So if you have two sides equal to each other and the included angle is not equal to each other, then the opposite side of the bigger angle is going to be bigger than the opposite side of the little angle. You see that? So this side right here is going to be bigger than this side right here if this angle is bigger than this angle right here. Are you watching? Because when I just say right here, you have no idea what I'm talking about unless you're actually seeing what I'm pointing to. All right? And that's it. It's kind of like what we did before, isn't it? Because you're talking about a bigger side opposite a bigger angle, a smaller side opposite a smaller angle. But it's not just in one triangle this time. We're comparing two different triangles to each other. Are these triangles congruent? No, absolutely not. They're not congruent at all. Okay, that's why they call it the side angle side what? Inequality. So they're not equal. This angle's not equal to this. If it was, then what would be true about the two triangles? What if this angle was equal to this angle? Then they would be congruent. Absolutely. Okay, but they're not. They're absolutely not congruent. But you can tell which side is longer than the other. Okay? Does that make any sense at all? All right, they have another one. Let's do this. It's it's exactly the converse of what we just did. What if we were given this stuff right here? What if I was given three sides? I got two sides that are equal. Do you see it? One tick mark, one tick mark. This has got 3, and this has got 3. Okay, they're exactly equal to each other, those. But what have I been given? I've been given that one side is bigger than the other side. You've seen this time and time again, haven't you, through geometry? They give you a theorem, and then what do? They flip the if and the then, don't they? All right, and that's what we're doing right now. That's called the converse. So instead of saying that this angle is bigger than this one, what did we say? This side is bigger than this side. Then what's your conclusion going to be, do you think? The angles are going to be bigger, right? So which angle is bigger? Let's call this ABC, just so I can, oops, ABC, and I put an X, because I was going to go XYZ. All right, look at this. So if AC is bigger than XZ, what do you think must be true about this triangle? Angle B must be bigger than what? Angle Y. Everybody see that? Do you see it's the converse? The first time we were given that the angles were unequal, right? This angle is bigger than this angle. So the opposite side of the bigger angle must be bigger than the opposite side of the smaller angle, right? You follow me on that? Okay, so that was side angle side inequality. But this time we were given two equal sides and one unequal side. So what do you think we're going to give that as a name? Well, you could say it's the converse of the side angle side, but look, I was given 3 sides. 2 were equal, 1 was unequal. So, no. Look, we call this the side angle side inequality. The angle was the thing that was unequal, correct? So, yeah, exactly. We're going to call this the side inequality. Does that make any sense to you? What does that mean? It means 2 sides are equal, but one side is what? Not equal, exactly. So if I have 2 sides equal to 2 sides, but my third side is unequal, then that's a side inequality. What can I figure out from that? Well, what I can figure out is the angle across from the bigger side is bigger than the angle across from the smaller side. And that definitely looks like it, doesn't it? That angle definitely looks more stretched out than that one right there. So, and that's absolutely true. That's the side inequality. Does that make any sense at all? Yeah, I think that makes pretty good sense. Let's do a quick example before we have to go. Okay, we've got this picture drawn now. So what they've given you is this. They've given you that JH equals GH. They told you this angle right here, okay, JHE was 6x plus 15. This one, EHG, is 65. Of course, this side's 11, this side's 9. let's just take a look before you even go through what they're going to ask here. What do we got? We've got this angle is going to be unequal to this. Would you agree with that? How do you know? Just because it looks like they're unequal? Right, because this is opposite 11, this is opposite 9. They're not going to be equal to each other. Okay. You've got this side, EH is equal to EH. So guess what we have? We have two sides that are equal, right? We got this side and we got this side is unequal. And we have this. I'm sorry, I said unequal, didn't I? Yeah. This side is equal to this side. Sorry, I was getting ahead of myself. This side is equal to itself, but this side is unequal to this side. This is bigger than this, so tell me something about this angle and this angle comparison. Travis, what do you think?
We have to use Converse.
Yeah. Well, yeah, but remember, we didn't say it was the converse of the side angle side. What did we call it? It was the last thing we wrote down. Side inequality, right? Because I've got two pairs of sides that are equal to each other and one pair of sides that are unequal. That's a side inequality. So if this is 11, this is 9, what does that tell us about some of the angles? Chandler?
Doesn't it say x has to be bigger than h?
Forget the x. Just look at that whole angle right there. That whole angle is 6x plus 15. Travis, tell me.
Well, JHG is bigger than EHG.
That's right. So this 6x plus 15 has got to be bigger than this 65. Would you agree? So let's write that down. So 6x plus 15 has got to be greater than 65. It's got to be bigger. Everybody understand that? Why is it bigger? Because it's opposite what? The bigger side. Right, it's opposite 11, and this is opposite 9, so this has to be greater than this one right here. All right. What they're asking is, say, what are the ranges for x? X can only be between certain numbers. What numbers can it be between? Well, this is the first start we have. Just see if this is bigger or smaller than the other angle. Well, it's definitely bigger than the other angle because it's opposite the biggest side. Let's do this real quick. Subtract 15 from both sides, so what do you get? 50, right?
Yeah.
All right. Just making sure my math is right here. Divide both sides by 6, and you could reduce it. Yeah, they say 8 1/3, okay? So they say 8 1/3. Is that all right? Did I do that right? All right, let's do this. We've got about a minute left. So it's got to be greater. So x has to be greater than 8 1/3. Now, this is the part that might be the part that you wouldn't even know what to do here. Let's look at the 6x plus 15. It's part of an angle in a triangle. You guys listening? This is an angle inside of a triangle. So all three of these angles add up to 180. But if we want to do another inequality, 6x plus 15, now you probably wouldn't have thought of this on your own, but I'm just showing you. 6x plus 15 has got to be less than 180. Wouldn't you agree with that? All right, that's another inequality. This tells you what x has to be greater than. This tells you what x has to be less than. And there's your range of numbers. All right, so you subtract 15 from both sides, and what's that? 6x is less than, what's that, 165? Divide both sides by 6. I don't know what that is off the top of my head. Let's see the book. It's 27.5, okay, or 27.5. So what are your ranges of possibilities for x? Because you can't really solve for x, okay, because x could be a lot of different, values. So x has to be between, Tamir, what is it? We were supposed to. I completely forgot about it. I guess we'll do that on Monday. All right, so 8 1/3 and 27.5. All right, so x has to be between 8 1/3 and 27.5, and that's the kind of stuff that you're going to do. All right. All right, there it is. So it's section 5-6. Make sure that's at the top of your page. There's your page numbers. There's the numbers 10 to 15, 17 to 20. That's due on Monday. All right, we'll take that quiz. The quiz is going to be section 5-3. All right. It's only section 5-3. That's the quiz.